Okay, next, what is the pressure exerted by 15.5 grams of methane if it occupies a volume of 10 liters at 25 degrees Celsius? Okay, so you should have a warning flag going off. Seeing here, we were given grams of methane, so we need to convert that into moles so that we can actually use this. So we're told our temperature is 25 degrees Celsius. Convert that into Kelvin is 298.15 Kelvin. V is 10 liters. R is 8.314. We're told our mass is 15.5 grams. Now, molar mass, what you do is you find the molar mass of carbon, which is 12.01, add that to 4 times 1.01, which is the molar mass of hydrogen. We should get 16.05 grams per mole. Then your moles is equal to mass divided by molar mass. So 15.5 grams divided by 16.05 grams per mole. And your moles is 0.965 moles. So that's the value that you need to use in your equation. So now we can go back to PV equals nRT. And we are looking for pressure. So I'm going to write this part out. PV equals nRT. We're looking for P. So we divide by V, divide by V. Okay. So our formula is P is equal to N times R times T divided by V. So we have 0.965, and include everything in your calculator, moles, times by 8.314 kPa times liters over moles times Kelvin, times by 298.15 Kelvin, all divided by 10 liters. So here we see moles cancel out there, Kelvins cancel out there, our liters cancel out, and we're left with kPa on the top. So we get 239 kPa, but we have 2 sig digs. So let's put that into sig digs. So we have 2.4 times 10 to the 2 kPa. That's your final answer. Okay. All right, last one. What is the mass of hydrogen gas contained in a 4.5 weather balloon at minus 25 and 102 kPa? All right, so we are told our temperature is negative 25, so you add 273.15 to that, you get 248.15 Kelvin. Volume is 4.5 liters. Our pressure is 102. R is 8.314. And we are looking for mass. So what we're going to do is find moles first, and then convert it into mass using our molar mass. Now keep in mind, hydrogen gas is a diatomic element, so it's H2, and that's why our molar mass is 2.02, because it's 2 times 1.01. Oh, no, I don't like it like that. Okay, so what I'm going to do is I'm going to look for moles first. Okay, so PV equals nRT. So I'm going to solve for moles. So PV over R times T. All right, so I have my 102 kPa times by 4.5 liters, all divided by 8.314 kPa times liters over moles times Kelvin, multiplied by 248 Kelvin. So this is all equal to our moles. So here kPa's cross out, liters cross out, and here our kelvins cross out. We're left with moles. So the moles that I get N is equal to 0.222247 moles. I'm given molar mass, because I know what I'm working with here. And mass is equal to N times big M. So mass is equal to 0.22247 moles multiplied by 2.02 grams per mole. My moles cancel out and I'm left with grams. So mass is 0.4494 grams. To sig digs, I need 2, so that is 0.45 grams. And that is your final answer. So now you should be ready to do your practice problems. I will leave the answer key and that you can check if you get stuck with anything. When you're done your practice problems, you can work on your study and review. I will see you next week. Have a great weekend.